Hi, welcome back to the channel. So in this video we are going to see a problem on Nyquist rate and Nyquist interval. Find the Nyquist rate and the Nyquist interval for this m of t is equals to cos 100 pi t plus 2 sin 200 pi t. So this is based on the Nyquist rate and Nyquist interval and the sampling theorem. For this, first we will write the standard form. M of t is equals to cos, so here we will write like this, and here it is 2 sine omega t, like this, right? So here we can call this as something like x1 of t, this something like x2 of t, right? So here, since we are written the standard equation, so my m of t is combination of this cos and sine. So compare this, I will call this as equation number 1 and this as equation number 2. Compare equation 1 and 2. So we'll get here omega 1 compared with this. So you will get as 100 pi, and this one omega 2, when you compare, you will get it as 200 pi, right? So here how to get this omega m is, it should take the maximum value of omega 1 and omega 2. So what is the maximum value of out of this 102 pi, 200 pi is, the value is 200 pi. So that is the value of omega m. Omega m is 200 pi. So once we get omega m, so you can easily get what is the value of fm. So omega m is nothing but 2 pi fm, where you can write fm value as, so here fm is equals to omega m divided by 2 pi. So what is the value of omega m we got is 200 pi, and it is 2 pi. So pi will get cancelled, so you will get 100. So that is fm value, you will get it as 100. The unit of that is hertz. So you get fm as 200 hertz, right? But what we should calculate is the question. Nyquist rate. So Nyquist rate is nothing but it is Fs, right? So how to calculate this Nyquist rate is Fs is equals to 2 times Fm. So this is the formula. This is also called as critical frequency, and it is Fs is equal to 2Fm. So now write 2. What is the value of Fm? That is 100. So what is the Fs? That is sampling frequency, or the Nyquist rate is 200 Hertz. So this is a Nyquist rate, right? So that is what they have asked here. Then how to get Nyquist interval is, so Nyquist interval is represented by Ts, and that is 1 divided by Fs. So we know that relationship between T and F, T equal to 1 by F. So Ts is 1 divided by 200. What is 1 divided by 200? So it is 5 into 10 power 3 we will get. So it is 5 milliseconds. So this is a Nyquist interval, right? So whatever may be the equation which they have given, so write it in the standard format like this. Then how many number of omega values you got, but you should take the maximum out of it. So whatever omega m, we know the relationship between omega and f, that is omega is equals to 2 pi f. Take this help and find out the message frequency first. Then after that, relate it with the help of this Nyquist criteria, that is Fs equal to 2 pi Fm, so that you will get Nyquist rate. We have called this as Nyquist criteria. In the previous video, I have considered the sampling theorem for oversampling, undersampling and critical sampling, so that if you go through that, you will understand this Fs equal to 2 Fm. So here, suppose if we draw this waveform, how we should get this sampling rate is, so here in the frequency domain I will write it. So this is just touching to each other, so like this. So this is just touching, so this is S of W, right? So this is 0. So this is omega m. What is the value of omega m here? We got omega m as, so here it is 200 pi. So it is 200 pi, right? So what is the sampling frequency? Fs. Fs is 200 hertz, right? So the minimum frequency you should have 200 hertz, so that you can able to represent this signal and also able to reconstruct this signal. So this is the condition of, this is minus 200 pi, right? So this is the diagram which corresponds to this Nyquist rate for critical frequency, that is especially Nyquist rate or Nyquist criteria, right? Thank you. We'll see in the next video with the next update.